All right, class, I had to redo the video because it did not record correctly in the classroom. So this is for people that missed class or the at-home students. Let's go for it here. So first things first, we are here. We are on the 22nd of January. We are still reviewing chapter 1. You have the study guide, hopefully. Hopefully you guys have done what you needed to do. And then in the classroom also, we talked about the students did not want their previous test to be handed back. So I did not hand that back. I will hand it back after the test on the 25th. So you do have a test coming up on the 25th. At-home students, you guys will be given the test on the 25th, and you will be given until, let's see, to the 26th, just 2 days worth in order for you to take the test. Actually, 27th would be fine. Yeah, as long as let's see, I will hand back the test there. So 27th was what your due date would be. So it gives you a class period to do it in. All right, so a few things here that we should do here. So as we're coming up on the rest of the semester, this is kind of important as we think things through. What would be best here? So on the 27th in class, I'll give you guys a final review assignment study guide. We'll do a few little things here. And then I'll hand back this test right here. I guess I should call it test number 3. I think that's what we're going to hand test number 3 handed back. And test corrections for test number 2 are due. Or I'll send those to you guys as well here. So we have kind of 2 tests that are kind of getting back to back. Test number 2 and test number 2, handed back corrections right there. And the students have a week to do it. And then I'll review the test corrections here. I'll hand back test number 3. And somewhere here, we'll have to review it here. Maybe after, because I don't think the presentations will take that long. And review. And let's see, actually, I should say this here. Test number 3, corrections due. Okay, now we're good. Just want to make sure that's there. So it's going to be Wednesday. We're going to do that. Okay, so presentations are on the 1st, and we have presentations and test corrections here. So for the at-home students, I'll talk about what presentations are in just a bit here. First things first, we should understand that there's no school on the 5th because of we're still going to meet here, virtual retreat. There it is. There's that one there. Okay, and I'll spell virtual correctly. So we're still going to be in school. We're still going to be online in school, looking at a virtual retreat, but no Algebra 2 class. And then we have ourselves the written final. And then something's going to be called a verbal final. And you know what? We should actually do that too. So let me kind of think about this here. At home verbal final. That's what we're going to do there. I'll talk to you more about the verbal final as it goes. In the semesters here, in fact, I might just do this here. I might just do this, and that'll be easier because then I'll be in the semester and I can start grading everything on the 11th. Okay. With that said, that's it. That would be the first semester. We'll take care of all those things here. So let's go on to presentations. What does presentation mean? So far in the class, we've covered the Appendix A, and we also did Chapter 1. And so a product or presentation is just a way for you guys to connect algebra concepts to something you have wanted to study more in depth, or something outside of class. Something that interests you, something that you want to dive deeply and find out about more. The way you're going to present it is a PowerPoint or Google Slides, some kind of presentation software. And if you want to have certain websites that go to it, that's fine too. We'll go from there. So that's kind of like the overview to the student. Here's my little letter to you guys here. So we've engaged in a few topics in algebra. We learned a few different algebraic functions here. Now it's your turn to think about how you've seen these things in your life. Do you see it on the street corner? Do you see it in art? Do you see it in music? Or what you can do is you can dive actually deeper into something that we've talked about in class. And so, I'll talk about some examples in just a bit here. But this process is really for you to tell a story. Tell a story, discuss what you think is awesome or at least interesting that you have stumbled upon or read through as you've studied the algebra concepts here. I do want to know what you're going to discuss. So you have to tell me, email me, probably the best way to do it. The only thing is I don't want 7 people doing this exact same topic. Then it gets boring. So I just want to make sure that maybe like 1 or 2 people doing the same topic, but they take it in from a different perspective. That's cool, but not the same presentation. Here's a little list that I kind of came up with on the fly. See if you guys can think about this here. So if you're into history and you really want to know some stuff, tell me where the word algebra came from. What's the origin? How did it start? Why did we develop this algebra system? Or then just some history of the development of algebra. So is there anything that fascinated you? Pythagorean theorem, for example, did that fascinate you? Like, where did it come from? How did it develop? What happened there? The other thing that we've done is we've studied functions in this class. Functions are super important. In fact, a lot of things in life have functions. We as humans, we like to quantify things. So we've made functions out of a lot of stuff. When I used to work at Fresno City College, the head secretary there, her husband used to work for the Fresno PD. And it was so neat. She was talking about the fact that they have a formula that what you do is you plug in what kind of weather you had, and then what kind of street you are. And I should back up a little bit here. He used to investigate car accidents. That was his job. He was the car accident detector of at least one of them. And so part of the thing is they have to determine how fast their car was going before it slammed on its brakes. That's important. Was the car speeding or not speeding? That's really important to sort of see and hear and think about as you go to trial, or this may lead to something else. Or who's at fault, really. It's determining who's at fault. So what he did is there's a formula. He showed it to me. I already forgot it. But he showed me the fact that it is a square root formula. And you put in how much damage the other car got. Then you put in the weather. Was it slippery? Was it dry? Was it hot? And then you put in what kind of road it was. So each of those are kind of numbers in of themselves. And so what happens, you plug in those numbers, and it should give you a pretty good, precise display of how fast the driver was going before they slammed the brakes. Again, it's just a function. Functions are all over the place. So if you see a function that's like, man, this is so cool, I wanted to present it to this class, go for it. Okay, second thing is, can you connect algebra with music? Is there some kind of connection between there? Now, how about art? How about astronomy? How about board games? Do you see algebra in board games? Is there a way to say, hey, well, I gotta quantify this and this? Now, computer coding is another one. That's going to be big. And then just really, can you connect algebra to anything that you've seen? So again, 2 different ways. Going deep into a topic that we studied in class, or connecting something to your life. So that is what the presentations are. All right, let me jump to, let's see, I did not have an algebra class last year. So I'm going to just show you just really quick here. Just a few presentations from last year's trigonometry class. Of course, everybody was on Zoom last year. And so this is an example, just kind of quickly. Let's see how many I can find real quickly here. So this is a presentation from last year. This person, Ajan, she decided, maybe you guys know Ajan Zimmerman. Atali better know Ajan Zimmerman. Anyways, She decided to do a historical perspective on somebody called de Moivre, or Abraham de Moivre. It's something we study at the last part of trigonometry. And so she decided, hey, I want to learn a little bit more about him. So that's what she did. And Sir Isaac Newton also, this whole concept of de Moivre's theorem. And so the book that he wrote, and then some other things that he is known for. And so it kind of went from there. And then she decided to give a little proof of one of the theorems that he came up with. Anyways, that's one possibility. Okay, that's the kind of like the history thing. Science, Trigonometry in Space by Christopher Doll. Here it is. So he did a PowerPoint. Let me kind of just run through these. And then actually he got to a website that showed an app.
And so here's the periphelion. You can see that it moves faster when it gets closer.
And so he was talking about space and Kepler's first law and how it relates to trigonometry. There it is. He did a PowerPoint. Yeah, I think this is actually a PowerPoint. Here's the website link, but he integrated it into the PowerPoint, which I thought was really cool. Okay, another. Oh, that's still Christopher. Let's go to this one. Let's see. Oh, yes. Okay. Dun, da, da, da. This is about skateboards. And so talks about how you classify different skateboards according to degree and degree angles. So that was part of it there. I thought that was so super cool. I would never think of something like that.
So yeah, you can see a difference here on that.
So what perspective constitutes a soft truck and a hard truck, and then what constitutes a trick board? So all the classifications are on skateboards based upon degrees, which is something we study in trigonometry. Thought that was so cool. Okay, and then one more. I think I have one more in here somewhere. Oh, yes. Boom. Okay, this is Jacob. Jacob did an awesome presentation on music and bass, particular bass lines. So this was so cool. And so he introduced it.
So there are many different genres of electronic music, a lot of different types of house music, tech, big room hardstyle, and then that's just like a festival, I guess. What we feel. Yeah, sign is a mathematical formula in music to measure time and frequency.
I'm gonna stop there. Again, awesome presentation, really well done. Talked about how one of the curves that we look at, called the sine curve, how it actually measures all the different aspects of different electronic music. Neat presentation there. So there's that. And maybe you know Jacob Tibbetts. That'd be awesome too. Okay, so with that, let's jump to what we're going to do next. So there it is. There's the project presentation piece that we'll go through at home. Students, what I'll do is I will send out an email or a Google Doc. And what you'll do is you'll just put in the times that you want to do it. You are going to do it on the 9th. If you cannot do it on the 9th whatsoever, there's really a problem there. Then what you're going to do is just, if you can't do it, we'll figure out another day to do it. So, but I do want you guys to finish it up before the 10th. That has to be done before the 10th. Or last scenario on the 10th, because then at that point I do need a grade and put in grades. Okay, with that said, what we did the rest of the period was we looked at, actually we had the family feud game, or the math feud game. So this one was a game that divided the room into two, and they had to figure out who's going to give you the most, correct points. You got to choose A, B, C, D. So there's a person up front that individual kind of gave credit, and then also the group can give partial credit for it. So let's go for it. I'm going to do just a few that we did in class. I'll just stop there for today. So this is a good review for the test itself. Hopefully this will help you. So let's jam with it here. So find f of -6. In fact, do this here. If you can pause the video, try to do this yourself. So this is review, and then pop the video back on. I'll explain it. We'll circle the right answer. We'll keep on going. So pause the tape now if you need to. All right, let's go with it. I'm going to go with it. So I'm going to find what is f of -6. This is a piecewise function. Do you guys remember piecewise functions? They are changed because of the domain. So if you have domain is in here, so we look over here first. And the question is, which function do I use? Because I'm trying to plug in -6, I'm going to use this one. Because -6 is less than or equal to -1. It fulfills this category. So then what I do is I say, okay, then that means f of -6 is going to be 9 times -6, which is -54. Boom. If you got B, you did great. Ding, ding, ding. There's the answer for that one. Next, number 2. All right, this one you have to know, oh, give me the equation of the graph. So you should first of all understand that this is a, notice all of them says g of x. So I'll use the same exact name for the function. So g of x, you should understand first of all, that this is a absolute value function. So first things first, you have something that looks like that. X that's inside the absolute value. But notice it's actually shifted. It's not here where absolute value would be if it was just absolute value. It's shifted 1, 2, 3. 3 units to the right. Okay, if it's shifted 3 units to the right, what we have here is an x minus 3. And if it was shifted to the left, we would have x plus 3 inside the absolute value. But I think you guys know this here. If it was to shift up 3 units, then it would have been like this. It would have been absolute value of x, just the x inside the absolute value, and then would have been plus 3 here. And if it shifted down, it would have been the absolute value of x minus 3. So there's your sort of 4 different ways you can go. And yes, in the horizontal thing, if you go to the right, it's a negative, it's a minus sign. If you go to the left, it's a plus sign because it works in reverse. To go up and down, it works exactly what you want to say it is. If it's a plus 3 going up, minus 3 goes down. So in this case, that one, and the answer is D. Dun, 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 dun. Next one. Number 3. Ooh, okay, let's start it here. The shape, again, you got to think about what the shape is, and I kind of give you a little clue here. There's an x squareds here everywhere. So let's say, okay, that's probably x squared. I'm going to leave some room to fill in things here. Just if I need to add or subtract, I can put stuff in here. If I need to add or subtract here, and if I can multiply, I need to put stuff here. Okay, so I'm thinking just like the last problem here, notice x squared by itself would have been right here, right? But this guy looks like shifted 1, 2, 3 units to the right. So I'm going to go minus 3. And then it's shifted 1, 2, 3 units down. So if it's shifted down 3 units, that means it has to be a minus 3 here as well. Okay, so I'm thinking to myself, that has to be the answer. I went to the right 3 units and I went down 3 units. So it's x minus 3 squared minus 3. All right, next. All right, this one is give you the graph and you graph it. So first things first, because this is x squared, that little piece there, I know it's not this one because that's absolute value function. So it's either B, C, or D. So now the question is, what does this minus 3 do? What is the minus 3 in the back of it? What does that do? Well, that's going to go down 3 units. That's all that does. So we have a parabola like this. Perfect. And then we're going to go down 3 units. And that looks like B to me right here. The parabola is still the same shape, still facing up, but just down 3 units. B is the answer. Number 5, go for it, very similar. So first things first, I see this square term right over here, so I know it can't be B this time. It has to be one of A, C, or D. So remember what this guy does. This guy shifts it to the right 4 units. And then it shifts down. Oh, not 4, not 2 units, sorry, 2 units. Okay, so I'm looking for a parabola. Boom, boom, boom. Shifts 1, 2, 3, 4, and then 1, 2. I'm looking for that guy there as the vertex. So there it is. 1, 2, 3, 4, 1, 2, and the answer is D this time. Dun, dun, dun. Awesome. All right, this one now. Ooh, this is absolute value, is that right? So this little function right here, that's absolute value. So first things first, A is gonna go away. D is gonna go away, that's not absolute value. Absolute value has a V shape to it. So it's either B or D, sorry, B or C. And so now we've got this little negative in front and a 2. So this little negative is called a reflection. And it's a reflection about the x-axis. So normally the absolute value is like this. It's like this. And now we're just gonna flip it over across the x-axis and looks like it's gonna be C. The other thing that you can play with is that little 2. That 2 just means each time it goes out 1 unit, it's gonna go up 2 units. So if it goes out 2 units, it's gonna go up 4 units. If it goes out 3 units, it's gonna go down 6 units. So that's what that little 2 makes. So it's a little bit more steep graph there. Okay, there it is, number 6. Number 7, go. All right, again, if you can do it before me, absolutely try it. G of x is the absolute value of x minus 5. Again, that little minus 5 inside the function means it goes to the right. 5 units from the middle. So which one takes 5? Oh, it's this one here. So 1, 2, 3, 4, 5. There's the critical point right there. The answer is D. All right, let's change gears now. Number 8. Number 8, I'd said in the class, it's really just find the inverse. That's what you need to do here. So notice the function itself is f of x. So finding the inverse, what we do with finding the inverse is instead of writing f of x, I'm just going to write it in terms of y. It means the same thing in mathematics, except for the fact that this is a function. That's all. But as far as graphing is concerned, it's the same. So now what we do is we switch. We switch the x's and the y's. So now we want to find a function that undoes the work of this function. And so for that, what we do is we add 24 to both sides. Then we divide by 4 everywhere here. Then we get ourselves y is equal to, looks like you can't divide x by 4, but you can use it as 1/2 or 1/4 x. 4 goes into 24 6 times. And then what we do is we have to declare that this now is the inverse function of f. So we go f inverse of x is 1/4 x plus 6. And I think you guys know the answer. This one's a tough one. This one kind of stumps some students there because I think we forgot how to do inverses. Now it's going to be on the exam, so you gotta make sure that you know that. Okay. Of course, another one like that. A little bit more complicated because it has a square root there. So, but the process is exactly still the same here. So f of x is equal to the square root of x minus 7. Change the f of x to the y. And what should we do to get rid of the square root or start solving? Oh, sorry. I'm getting ahead of myself here. I have to switch my x's and y's here. Switch the x, switch the y. Okay, now let's solve for y. So algebra techniques say, let's square both sides. X squared is equal to y minus 7. So all we got to do is just add 7 to both sides. Here's my equation. Flip it around. And then declare that this guy is the inverse of my original function. And what does that say? It's b. Okay, the only little condition here is this, notice it's x is greater than or equal to 0. And the reason for it is because remember when you have a square root, you can't have a negative inside there. So when you take the other way around, you say to yourself that that can't be x has to be either 7 or greater inside here. But the output is going to be either 0 or larger. That's why that was changed. Okay, jam. Oh yes, this is the one we stopped on here. So this is a pretty cool function, actually a real life function. Here it is. If you want to go from Celsius temperature and you want to go to Fahrenheit temperature, what you do is you use this equation. Okay, so then we go like this. We go with 5/9 x minus 32. Okay, so then we go like this. We are going to simplify it. Let's see, same thing that we're going to do here. We're going to change this up to a y. I'm going to multiply by 9/5. Multiply by 9/5 here. What's going to happen here is that these 9s are going to cancel each other. 5s are going to cancel. Sorry, class, I'm so sorry. 1 second, sorry. We change it to a y. And what we got to do is we got to switch the x's and y's first, right? Switch the x's and y's. There it is. Okay, now we solve for y. So first thing we're going to do, I'm going to change pen color here. So we're going to have to undo this little 5/9. So the way we undo it, we just multiply by its reciprocal, like that. The 5s cancel here, the 9s cancel here. Now we're left with 9/5x, y minus 32, plus 32 plus 32. So y is equal to, looks like 9/5 x plus 32. Okay, then we have to declare again that this is the inverse function. All right, and the question is, what does this mean? So let's see. Originally, if this is the formula that takes Celsius and gets you into Fahrenheit, well, that means if we do the inverse function, this formula here takes Fahrenheit and converts it into Celsius. That's cool. That is exactly what an inverse function does. It's going the other way, other direction. Okay, so we're going to go with that. All right, and that's how far we got in class. So I'm going to stop there as well. Hopefully you enjoyed the video. Hope you learned something, and hopefully that helped you to review for the exam.